And now we have our first very special speaker, similarly to last year's conference program, where we have introduced speakers from Africa. And that's, of course, deliberate. That's part of our plan to treat frontiers, not only in the technological sense, but also in geographical, cultural, and any other sense. And of course, Africa is a great, fantastic place with incredible potential, with fantastic resources of people, first of all, and any other resources, of course. This year, we are very fortunate to have 4 speakers. We didn't create a separate program for Africa because the topics are in various fields, so they will be scattered, but they all represent African computing and supercomputing achievements. And our first speaker in this Focus on Africa part of the program is Dr. Tshiamo Motshegwa, who works at the Department of Computer Science, University of Botswana. Dr. Tshiamo Motshegwa is an academic who works at Faculty of Science, University of Botswana. As I said, he's a lecturer and leads the High Performance Computing and Data Science Research Cluster and the University Industry Government Co-Creation Platform. He received a Bachelor of Engineering with honors in Computer Systems Engineering and PhD in Computer Science and at the School of Mathematics, Computer Science and Engineering, City University of London, UK. He has had visiting fellowships at British Telecom Research and Innovation Labs, at Intelligent Business Systems Group in Ipswich, UK, and fellowships at UNESCO International Centre for Theoretical Physics in Trieste, Italy, and internships in British Energy in UK. Dr. Motshegwa serves on the Botswana government's Ministry of Tertiary Education, Science and Technology task team for the Botswana Space Science Strategy, overarching developments and opportunities in space sciences and technologies. He serves to engage at the ministry regarding the National Digital Transformation Initiative for research, science, technology, innovation, ecosystems through cyber infrastructure for digital revolution, capacity building, and digital skills. Welcome, Dr. Motshegwa.
Thank you very much, Marek. I think you're going to have to give me 5 more minutes, given that lengthy introduction. But just to thank you and your team for inviting us again to participate in this conference. It's a real pity we cannot travel to Poland. I have very, very good memories of Poland, having visited Krakow in 2003 and had an opportunity to visit one of the underground salt mines in Krakow and discovered that Copernicus comes from Poland. So that was really a fantastic time that we spent there. This presentation I'm going to make is because I'm wearing a number of hats that we just enunciated there, Marek. But I think it's mainly a very light presentation made to really bridge the gap between us and the rest of the world insofar as building potential relationships for collaboration. I'm glad that you were mentioning collaborations there. I think for us in the continent, we are constantly trying to build this relationship, especially given the upcoming or ongoing Africa-EU partnership for investing in people, technology, science, technology, and other things. So really, it's more of a very light talk to let you know what we are doing in the continent on some of these very, very important enabling areas regarding creation of a cyber infrastructure to provide support for open science. And I really want to appreciate the passion you gave at the very outset regarding some of the global challenges that we all face, that we all know now has to be addressed through collaboration, not competition. And indeed, some of those challenges also provides opportunities for the continents and for each member state. So I wanted to highlight that slide there just to show that for Africa, there's great potential in solving some of our challenges and priority areas through what I'll show later as open science. You can imagine it's a continent that is endowed with riches of natural resources. You'll see there a map of all existing diamond mines in the world and diamond deposits. And you can see that most of them are in Africa. You need very, very good approaches to be able to do some of these explorations in the future. You see there at the center, the view from space of one of the World Heritage Sites, the Okavango Delta in Botswana. Earth observation is a key area in terms of looking down on the Earth. And also, if you look at biodiversity, et cetera, et cetera. So there's great potential in using open science and obviously science in general to solve problems. In fact, Africa has very, very good detailed policy instruments that enunciates how we get to the Africa that we want through the prism of science and technology. And these are very good blueprints that provides us with a direction, with a compass of how we can use science and technology. And if you look at COVID, there's also great potential. 50 years after independence of most African countries, we're hoping that our innovation and research ecosystems are advanced enough to be able to help obviously tackle African problems. So I wanted to show this slide also to highlight potential areas of collaboration and cooperation going forward, so that participants of your conference can potentially look at these areas and thinking, how can you collaborate with African institutions? In terms of open science itself, I believe that everybody here, probably even from your interaction, Marek, appreciate what open science is. But primarily the definition that resounds, I think, with most people today is that science must be engaging society in terms of framing scientific problems and also thinking about how they are going to lend to make sure that we don't work in ivory towers as scientists. And of particular importance is the need to also look at potentially making our data sets as open as possible. We cannot open everything, but as open as possible, but in particular, making sure that we have these data sets in accessible manner, in interoperable systems, interoperable data sets, they are usable and findable. This is critical, especially if you're going to automate things. So I think that's a very good slide. And UNESCO itself provides very good recommendations of what open science is. And also important is access to literature, to make sure that we can all advance together. Access to literature in an equitable manner is very, very critical. So really it's very, very paramount to have mechanisms to support open science. Now, in terms of why open science, you can look at some of those motivating factors there. In principle, everybody agrees that is very, very good scientific practice to communicate your evidence. In so much as that you publish, you must also publish your data so that if at the very minimum, reproducibility of your work can be conducted. I think this is a very, very important point to make. The second point, they also highlight that it's very, very apparent that open data practices have really advanced a lot of areas. We just had a talk there in terms of physics. There's good progress in astronomy, in terms of sharing data sets in an open manner, remote sensing. And this is critical because if you open up your data that way, you can actually use data at scale by machines in terms of harnessing the technological potential. And of course, the last point emphasizes the importance of this as far as fostering innovation is concerned. And of course, in terms of the benefits, we see the benefits there across all the spectra. And again, it doesn't need re-emphasizing. Collaborations are also potentially can be enhanced through open science. You can see there the map of Europe, how you are collaborating very well, and Africa is still very, very sparse. And we think that through creating platforms for open science, we can actually change this picture to make sure that we can enhance the collaborations here. And if you look at where the trend is now, the globe is looking towards building these global open science platforms to help us collaborate, not compete. You mentioned very, very important areas of climate change, SDGs and there. Disaster recovery is also very critical. The globe is looking towards building these platforms where we can engage. And you can imagine that in Europe, you are doing great work with your European Open Science Cloud to make sure that as Europe, you collaborate as well. And indeed, underlying all these open science platforms is the need for these cyber infrastructures. I think that diagram captures it very, very well, the different components of a cyber infrastructure and what it entails. In particular, you'll see that the issue of data is very important. The issue of sharing this computational platform that your colleagues were talking about is very important. Again, apparent is the need to actually know who is doing what in terms of expertise. So that's a very powerful diagram there as well. And again, on top of these cyber infrastructures, I think colleagues have talked about advanced services that can be offered, and it doesn't get more clearer than showing that data is coming from all sorts of directions in all sorts of the sciences, not just the physical sciences, but also even social sciences. I think it's very, very important to be able to highlight this, especially if we want to build a case to governments, to politicians regarding investment and return on investment in some of this system, to showcase that these things are overarching and widespread, not necessarily in one areas. And again, I can't emphasize enough, there's progress elsewhere in the world regarding the CIs. You know about your systems in Europe. Some of them have just been explained in America as well. There's very, very good work over the years providing these platforms to support scientists. So really, the emphasis is also the need for investments. I want to come to this conference to show that really investments in some of these areas are still behind, for example, in Africa. And we need to be creative about ways how we can democratize access to these infrastructures amidst the lack of resources. You can see the numbers there. Most countries in Africa are probably thinking about, do I invest in a hospital or do I invest in a supercomputer? So more often than not, you can understand the politics of what that it entails. But nonetheless, the idea is to create, like everywhere else in the world, a platform that can help Africa solve its own challenges through open science. At the same time, obviously collaborate with the world. So one of the first things that I want to show in this presentation is exactly that, to highlight some of the work that has been done to try to get Africa to a state where we can collaborate with the rest of the world, but also solve our own problems. And that came about with a project called the African Open Science Platform. A very, very good pilot study was done to see where Africa is along the prisms of infrastructure, the issue of data, the issue of skills, the issue of access to scientific literature. And that study showed obviously very good progress in some areas and also not so good progress in some areas. And it proposed a number of things that needed to be done. First of all, enunciating a very grand vision of where Africa and African scientists want to be in the new dispensation of doing science in the digital era. And of importance, those 4 areas were highlighted, that there's need to really develop these federated computational facilities across the continent, coupled with obviously the necessary policies and best practices for doing research data management. An important aspect is also that of skills, to make sure that African scientists are skilled and are up to par in terms of doing science in the 21st century, insofar as digital technologies. And very, very critical is to identify a number of collaborative projects that as a continent we can collaborate on to make sure that we obviously advance as a collective. And there's 2 bullet points that highlight the need for these networks of education and skills, of data and information, but critically, network of open access. Remember, to make sure that we advance, we need access to scientific literature. It's not very, very cheap to access journals, even more so in Africa. So it's very critical maybe to look at open access as a way to maybe advance this dispensation. Maybe just to highlight some of the great areas for collaboration with Africa in this era is the issue of space sciences. In fact, Africa has developed an African Space Agency through a statute. Again, it shows the importance of space sciences, especially Earth observation, insofar as solving some of the challenges in there. So it's a very critical area for us in terms of exploiting it. And if you look at a typical space science strategy, it will really show that infrastructure is a key thing here. Most of those African countries that you saw there, 15 of them that have got space agencies, do have to create an enabling infrastructure to facilitate all that work. Indeed, projects like the SKA project demands that we have these infrastructures to allow us to collaborate as partners in these projects. And at a regional level, in terms of regions in Africa, the Southern African countries are also looking at space as a very key area to collaborate on, which is why in 2016, the ministers approved a cyber infrastructure strategy to help us develop the diagram that I showed there. It's a combination of a number of countries looking forward to collaborating on data and compute intensive projects of regional importance. And there needed to be a framework, an instrument, a policy instrument across the countries to facilitate that interaction. And indeed, that has been approved, and it leveraged some of the instruments, some of the policy instruments that the ministers themselves had approved a couple of years before or decades before. And indeed is situated nicely in some of the frameworks that the ministers approve. Indeed, you can see the potential there in terms of if such an infrastructure is in place. These are the great things that you can do. You look at genomics in terms of human heredity and African genomics. These are key areas that Africa can look at from that point of view. We've met a couple of times over the years to make sure that we collaborate in these areas. We host and attend a national HPC conference in South Africa where we deliberate on these matters. And we also deliberate on the issues of infrastructure. And we need partners. And we've had partners in terms of helping us on this journey, especially on the infrastructure side of things. So the next slides that I'm going to show you at a university campus level, what we've been trying to do to make sure that our university campuses are equipped with some high-performance computing facilities, modest as they may be, but still enough to promote good research on campuses. Indeed, you may have heard of this story where we engaged with TAC in terms of acquiring some compute nodes, and these were commissioned in various countries in Southern Africa. And indeed, universities like mine, University of Botswana, the computer science department, we've commissioned some of these, we've trained some of our systems admin, and we are currently supporting a lot of research going on. Quickly, we do have a very strong capacity partner with South Africa through the Center for High Performance Computing. They've trained some of our guys in terms of systems admin, and we are grateful for that. They have a petaflop system in the Southern Hemisphere and Africa, and it's really quite good to have a partner like that. We've built some very good clusters, and we've had, obviously, visits to some of these supercomputing clusters that are collaborating with us. Indeed, it would be very, very opportune maybe to consider some of the supercomputing clusters in Europe for such a collaboration. And this was very eye-opening because being on the ground, engaging engineers and scientists there also provided us with an avenue. Very, very quickly, we also very good partnership with ICTP that allows us to be able to engage with them, especially on these academic HPC data centers and the skills that are required. And more importantly, also in regard to data science training. You can imagine you got your infrastructure, you have to make use of it. And this is very, very critical. And finally, I have to emphasize that these systems are as good as what are they used for. I want to show you the impact we have there. At University of Botswana, for example, at the various departments, we have a number of research groups, research professors working on some very good areas. We've graduated a couple of PhDs that would have otherwise taken forever to finish because now they can do some simulations on these systems. And we have a number of projects that I want to highlight there, Marek, in terms of what is happening. So I think I'll stop at that slide just to emphasize that this is going on. And in particular, there's also need, you'll hear a talk tomorrow about regional projects that is being used to try to get us to work together in the area of weather and climate. And I think this is critical to make sure that the infrastructure we develop is not just white elephants, but they've proven what they can be used for. And I think that's an exciting project that Dr. Bopape tomorrow will talk about. And finally, we need member states to be able to obviously do the necessary in terms of investments, in terms of policy, and in terms of driving their own institutions to be able to collaborate in this regard. Thank you very much.
Thank you very much, Dr. Motshegwa. That's very interesting, very fascinating story. Let me just add that there are some extremely talented young people coming from that region, and the team from South Africa, which is a neighboring country from Botswana, has won student cluster competitions numerous number of times, especially in Germany. They come to Germany for the last 6, 7 or so years, and they each time they come, they win. Maybe once they were second, but that's a fantastic achievement. So definitely you have fantastic resources. You have the most talented people and enthusiastic young scientists and engineers. So the future should be really bright, especially if there is openness to what you have said.
Yes.
Let me check if we have. Incidentally, I would love to engage in longer discussions with you, since ICM is very, very heavily involved in open science and open projects and open access, and we have at least maybe 40 people working on that and making scientific literature available in open access. So that's and that's what I emphasize. It's not only sort of technical resources, but also access to knowledge and discovery. So it's super important.